So I think it was like 3 months back I did a talk on MCP protocol. And this is the follow-up talk from that on Google's A2A protocol. So MCP is a protocol for agents to talk to tools and get context. A2A is a protocol for agents to talk to agents and interact with each other. And we'll see how that plays out. This is me. I'm a bit of an avid astrophotographer. It's out at Godley Head, and it's the planet Jupiter rising up over the ocean. So if you want to see the code for this, that's the repository. Okay, so the demo for tonight is based around chess. So basically going to have one agent that manages the chessboard and then a black player and a white player agent that play the chess game. And to make it really interesting, I'm going to make both of those guys dumb and they have to talk to a chess grandmaster to get ideas on what move is next. So these agents are going to talk using the A2A protocol, and these player agents are going to talk to the chess grandmaster using the MCP protocol. Okay? So the chess grandmaster is basically just a tool that it can basically tell it the state of the board and get a move back. Okay. Did I just jump through? Yep. So I'm going to quickly talk about agents. So last time I talked about a thing called a React agent, which is an agent that reasons and then acts. So it reasons about what it needs to do next, and then based on that, it takes an action. So this is a plan and execute agent, which is just a big brother of that, really. It makes a plan, creates a task list, it chooses a task off that list, and it does it. And then it works its way through the list and assesses as it goes along, is the plan complete? And if it feels the plan's complete, it stops. So basically, it's using a large language model to make a plan. It has a bunch of tools that it knows about how to use or what they can do. And part of that plan might be to use some of those tools. Jump in and ask questions anytime. So I'm just going to quickly talk about computer chess. So to play computer chess, we need a way to describe the board. And the way we do that with computer chess is a thing called Forsyth-Edwards notation, which is this big string of characters across the top here. And it's basically just a description of each row of the board. So the first row, the rank 8 is rook, knight, bishop, queen, king, bishop, knight, rook. And row 2 is all pawns. And then the next rows, it just says that they've got 8 blank squares. And then we're into the whites, which are all in capital letters. So all the white pawns, and then the bottom row of the board. So it's a very simple notation, and large language models understand it as well. So I can pass this to a model, and it knows what it is. So that's what I'm going to use to describe the state of the board to the model. And the other thing is a thing called UCI notation, which is just a way to describe a move. And it's really simple. It's just the square that you started on and the square that you ended up in its position on the grid. So E2 to E4. So it's just giving the language models a way to think about these things. So I'm also going to use a library called Python Chess. It's a pretty cool library. So it understands UCI notation, which is the chess moves, and it also understands Forsyth-Edwards notation. So it can basically perform these moves and give me the Forsyth-Edwards notation for the state of the board after it's done those moves. Right. Sounds really complicated, but it's just basically making some moves on the board and then describing what the board looks like after those moves. And it's also really cool because if you give it Forsyth-Edwards notation, you can ask it to actually draw the board and show you what's happening. So we've got basically two ways of working with this chessboard. One is in terms of language using Forsyth-Edwards notation and UCI moves, and the other is the board itself. So this is how I built it out. So I'm using a tool called Gradio for the user interface, and it's a really cool tool. It allows you to quickly build user interfaces for Python programs and try them out without having to do anything clever. It's basically a declarative way of describing user interface. I've got a piece of Python code that uses Python chess just to manage a chessboard. So I can tell it to look at the board and I can give it a move and say, is this a valid move on that board? And it'll tell me if it is. Or I can tell it to make a move on that board and change the state of the board and then ask it for the fen notation to describe that state of the board. And then I've got an orchestrator agent, which is basically just going to talk to two player agents. And it just manages turn taking for the player agents. And it also does a little bit extra. The chess game manager provides a bunch of tools that it can use. So it can make a move on the board using a tool. It can also check if it's a valid move. It can also check if the move that these players have given are valid moves. Okay. And each player, so the orchestrator agent is just a normal agent. It's not a special agent. It's built using Google's agent development kit. But these agents are A2 agents. So they're wrapped so that they can use the A2A protocol to talk, basically. And I'll show you what this means. It'll make more sense. And then these agents are talking to tools over the MCP protocol. So they're talking to this chess engine down here and saying, this is the state of the board, what's a good next move, basically. That's the master. It's the chess grandmaster. Yep. And actually, this is the chess grandmaster here. It's a stockfish chess engine. So it's actually better than grandmaster level. But this leaves grandmasters in the dust by quite a long way. And it's something you can just run on your computer, which is crazy. Yeah. So there's a Python library that basically just wraps that engine for these tools. So that's what I'm going to do.
Is Stockfish just able to play through all the possible outcomes from a given point to figure out what's the best?
Yes, it has some very clever algorithms, but basically it does a form of tree pruning to work out what are the best next moves without having to traverse the whole possible move space.
Yeah.
So that was the Go one. Couldn't do that, could it?
Well, yeah, so this was done a long time ago, beating grandmaster chess players, but Go is actually much more of a challenge, and it is done now. We do have engines that can play Go and beat the master players, but it took a lot more time to get there.
And it's a lot more computationally expensive, isn't it?
It is, yep. There's no need to do all of this other than to show you guys how to use these protocols. You can actually just connect this chess game manager straight to the chess engine and skip all this other stuff. But then we wouldn't get to learn about the thing that we're here to learn about tonight. So this is what it looks like. There's a Gradio UI. Python chess is running the game manager. A Google ADK agent will run the orchestrator. These are also Google ADK agents, but they're wrapped so that they can use the A2A protocol to talk to each other. And then this is using fast MCP, which is just a quick Python tool to build MCP servers. So if you've got a Python function, you can annotate it to say that you want it to be a tool, and then you can start up a server and access those tools. And I'm going to show you what all this looks like. So the A2A protocol, what we're about to hear tonight about, it was Google's baby, but they've actually given it to the Linux Foundation as of June. So it's now under their governance, so it's an open protocol, and that's really helpful because it's helping, it's not locked into a vendor, basically. So what is the A2A protocol? It's all of this crazy stuff here. So there's a thing called an agent card, which it provides, which describes what the agent can do. It tells it what the agent is and what tools it has as a bunch of skills. There's the server itself, which uses JSON RPC, remote procedure call. There's messages, which have a role, like agent or the user. They have parts. Parts can be text parts, file parts, data parts. We have tasks, so a task that we give to the agent to do, and that task might involve sending several messages. And as a result, we get things called artifacts, which is what we want to get out from the agent. So it looks like a lot, but in the end, it doesn't end up being much when you actually use it. So a client agent can request a card to find out what another agent does. It can send a task to the other agent for it to process. As part of that task, there'll be a bunch of messages which have parts, and it sends status updates on what's going on back. And finally, we get an artifact. That's the result. You don't have to deal with much of this, but this is what happens behind the scenes. So this sort of takes it out a little bit more. So discovery, basically it asks for the agent card to find out what the agent can do. And then once it knows what the agent can do, it can send a message which has a part, and that part describes a task which it starts running. It sends messages back saying how's that going, and when it's finished, it finally sends a message with a part that has an artifact, which is the result. It sounds like a lot, but it actually ends up being not much. So this is what an agent card looks like, and the way Google has it set up is these are auto-generated. So once I design the agent, this gets created automatically. So it's just got a general description and then a bunch of skills. So this first skill here is the actual agent itself and what it can do. And then the rest of these skills are tools, which use a large language model to do a job. So there's a tool here, planning. Can think about the task to do and make plans. So I've actually given this agent a planning tool. We talked about it before. Giving an agent a planning tool allows it to make a plan and then follow through on it. So it's got a planning tool here. It's got a tool that allows it to get legal moves. So it can say, this is the state of the board. What are the legal moves from here? So there's a whole bunch of tools that it knows what they do, and then it can reason about which tools it wants to use. So this is the main one here, get the next best move given the board state from Stockfish. And that's the one that we want it to use. It does some other things. It gets the board state and it checks if it's a valid board state. If it's valid, it passes it to Stockfish. It reasons about all of this. It says, next thing I need to do is pass it to Stockfish. Pass it to Stockfish and gets a move back in UCI notation. It checks the move to see if it's a valid move. If it's a valid move, it passes it back to the agent that called it. Okay. So this is using Google's Agent Development Kit, and it comes with a whole lot of just really simple tools to use. So the first one I'm going to use is MCP toolset. And I basically just say, this is my MCP server. This is where it's located. and it has these tools. And it automatically wraps those as a bunch of tools that my agent can use. So I don't even have to think about it. It just talks to the MCP server, finds out what tools it has. I've told it to only use these tools from that set, and now they're available to the agent.
This is the client side.
Yeah, so this is the agent talking to an MCP server.
Yep.
Okay, so this would be one of the player agents, and it wants to talk to the chess grandmaster MCP server to get the next move, basically. And so it can validate the incoming state of the board, get a move, validate the move, and it can check legal moves and get the game status. Okay, so this here is just a Pydantic class, base model class, to get it to basically make sure that the move coming back is a valid UCI move. So Pydantic handles all of that. So this is the actual agent itself. So it's the black player. It's going to use the Gemini 2.5 Flash model. It's got a name, a description of what it can do, and an instruction. And the instruction basically tells it how to go about this, it says. And it names the tools that it needs to use. And it uses the exact name of the tools so that it doesn't have to sort of guess. And then this last one here, I've asked it to give us what's called a structured output. So I call a tool that's actually just part of Google's agent development kit that basically sets the model response to what comes out of the rest of this reasoning. And it sets it using that Pydantic class to make sure that it is a valid move. It pulls in the tools here. It uses the chess move output schema to make sure that it's a valid UCI. Here's the planner here. So I'm giving the planner some thinking config. I want it to include its thoughts when it returns things. I'm giving it a thinking budget, which is 2,048 tokens of text. So it's only allowed to generate that much text, and it hardly ever generates that much. I've also, I'm not quite sure where I do it, but I also basically tell it how many calls it's allowed to make without asking me. In fact, it's there, yes. So it can basically make a number of calls to the language model without it having to ask my permission. If you set that too small, it might not be able to use enough tools to complete its reasoning process. And then there's just some safety stuff that you can set so that the model doesn't return anything weird. So, I mean, that's basically the whole agent for the player agent. So it just grabs some tools. And then Google has this really lovely wrapper that they've created. So I don't even have to think about how to make this into an A2A server. I just say this is an A2A agent and I want to turn it into an A2A server and serve it. And it does that. Which is really nice because that piece used to be really complex. It used to involve several quite large files and a lot of hand crafting stuff. So it's really nice to actually have that. And Google's not the only player that's creating a framework for using this. Pydantic AI has started their own. I had a play with that and it's not quite as mature as this yet, but I suspect it will become that way pretty quickly.
Remind us what root agent is.
Okay, so when you create a agent development kit agent, the root agent is just the main agent for that agent. So it could have sub-agents. In this case, we're not actually using well, we are, but we do it a different way. This is just a curl, which I can send to the agent, and you can actually just see how the protocol happens in a raw form. So it's JSON RPC, it's a message and I send it, and this is the structure of the message. It's got an ID, a role, some parts. The text part has the FEN notation in it. So it's not actually super complex how to send it to these agents. I will show you what the result of that looks like later on. Okay, so let's switch out of here and let's actually look at some stuff that's actually running. And hopefully the demo gods are going to be kind tonight. So this is what's called the MCP inspector. So it's a tool for looking at any MCP server and trying to interact with it just to find out what it does. So it's a development tool. So I want to look at this. This is my MCP server, Chess MCP server. This is the Chess Grandmaster. And I want to find out what tools it has. So hopefully we'll get a connect. Yep, so get a connect. I'm going to click on tools and I'm going to ask it to list out the tools. So those are the tools that we saw before. Get stockfish move. And I can click on a tool. I need to get a valid FEN. So this FEN notation here describes the starting positions of a board. So it's just basically asking, saying the white player plays the next move, what is that move? And it'll be moving a pawn, basically. So I'm going to feed that into here and ask it to run it. And it's come back with move from E2 to E4. So it's pretty simple, and you can validate that move. So I can say, is that move valid? So I stick it in here. Oh, actually, that's validate FEN, validate move. So given that board state, is E2, E4 a valid move? Yes. No. So that's the Grandmaster, and we haven't actually looked at the software behind that yet, but it's up and running and providing tools.
Will stockfish always make the same first move, given that it's playing right?
Most of the time, yes. It's often this move. Occasionally, no. Yep. Okay. So let's have a look at an agent. So the agents here are Google Agent Development Kit agents. So I can actually run them as agents by themselves without wrapping them so that they can be used as an A2A server. So we'll do that first. So I'm just going to, let's look. Yeah. So Google, sorry, this is a little bit hard to see, my apologies. Let's see if we can make that. It's going to take a moment to resize that. So I've just asked it to run ADA web. So it's actually in a folder where there's a bunch of agents, and this web server will actually run up and provide those agents so I can test them. So it does all the plumbing. So it's gone and found the white player agent in this file. And it provides a web interface. So that's provided on 8080, which is here. So this is the actual white player agent. So I'm going to pass it a FEN notation describing the board and ask it for a move, and it's going to go away and grab those tools and reason about how to use them. Just going to refresh this to make sure that. Okay, so here we go. It's going, my approach is generating white move. I need to check the fen's valid, validate fen's validated. Okay, now it's valid. I need to, it's zooming through. I'll bring it back. I need to make a move. I'm going to use Stockfish to do this. Now I've got a Stockfish move. I need to check if it's valid. I checked it's valid. Now I've got a valid move. What do I need to do? I need to use the set model response tool to let it know that this is the answer, and the answer is move E2, E4. So I can see all of its thinking just using this tool. So it's basically gone and reasoned about those tools and said, this is the process based on what's described, and it's gone through that and produced a move, which I think is pretty cool.
Do you give it any sort of tone instruction? Does it naturally say
No.
room for error at this stage?
Oh, no. I mean, this thinking is just nuts. Sometimes it just has crazy thinking, but it all comes out in the wash. It's amazing. And if it comes up with a bad idea, it actually replans and says, oh, that was a bad idea. I need to try this. But it doesn't actually happen that often. So I've instrumented all these agents using a tool called Agentic, which is just a really small bit of code I can add. And it allows me to see what all of these agents are doing. So if I go out to that, so here's the last trace, and it was the white chess player, and it's actually got the whole trace of what it did. So that's my strategy, that's the process I'm going to use, and the next thing is to validate. It validates it using the validate tool. It's valid. Then that's the instruction for the model, and that's its planning. It does a little bit more planning, and then it calls another tool, gets another answer, does more planning, another tool, and it finally gets a move, and it does quite a bit, and then it basically sends it back. And these tools are quite good because they not only track what the agents are doing, but you can actually look at what it's costing you as well. So those models today have chewed through 4 million tokens. Yeah. Okay, so that's the agent development kit agent, and then we just had the 2 A2A, which wraps it into an A2A server. So we can actually look at it as an A2A server. So this is inside a Docker container, and the name of the service is White Player Agent, and it's on port 8005. And I'm just going to connect to that using the A2A inspector. And the first thing it does in that process that we're looking at before is it grabs the agent card and finds out all the capabilities that the agent can do. And if I grab that thin notation, and put it in here, send it off, basically, this is the White Player agent sending it off, and then there's all that tool use happening, and then an answer will come back. So we'll just see the answer that comes back. It's gone through and validated the input, got a next move. And so that curl that I showed before, this is what it would have produced. So there's the artifact, and the artifact is what A2A outputs, and it's got the move in it. And then this is the history of the conversation here. So all the messages in the history that it's been having with the language model. And It's reasoning. So these are all the messages that are going back and forth. And then, where are we? That's the last message, which sends the move back. And then it does log how many tokens we used while it was doing this and some other information which is useful. So that is the player agent. And it's talking to the MCP tools. It's using the A2A protocol to serve this up so that the orchestrator agent can talk to these guys over a network. It's talking to the MCP tools over a network using the MCP protocol. The MCP server is providing those tools and talking with the Stockfish engine. So, what I want to show you next is actually running. Let's okay. So I'm running all of this in a bunch of Docker containers. So there's a container for the white player agent, a container for the black player agent, a container for the MCP tools, and a container that has the chess manager, the UI, and the orchestrator agent all in the same container, so they can share state really easily. And so you can see it's checking agent cards here. It's doing a little bit of health check just to see that things are available. I'm going to spin this up so that so this is the user interface. So this is Gradio, and I'll talk a wee bit more about Gradio in a moment. But basically, when I hit start game here, it's going to send a message to the orchestrator agent, which just says begin game. And the orchestrator agent's got a bunch of instructions, which I'll show you in a moment, that will allow it to use those agents. In fact, let's do that quickly. Okay, so it's much the same as we did before. Before we used an MCP toolset to grab a bunch of tools. This time we're using this wrapper called remote A2A agent. And so it's basically taking a remote A2A agent and then rewrapping it as a Google ADK agent. So that I can use it with other Google ADK agents.
Using the card information.
Yep. So it's basically gone and got all that information from the card and then built an ADK agent based on that that talks to that remote server. And then I actually wrap these agents as tools because I want to give them to another agent that can actually use them as tools to do a job. So all this is here is turning an agent into a tool. And then, same as before, the root agent, the model that we're going to use, description of what it does, and then instructions. And it tells it about the tool. So use the white player agent tool with the fen as input to get the whites move. Okay? So it's going to reason that that is the tool that it needs to use to do that. And it can apply the move. So the chess manager also has a bunch of tools that we've wrapped. And it's going to use that tool to actually make a move on the board. And then the black does white player, apply move, black player, apply move, and then repeat. So it's not particularly complicated. It's allowed to ask for the game status just to check if the game's finished or not. It can check the fen to see which player it should be, because it'll have a W for white as the next player or a B for black as the next player. And then apply the move and just continue. and stop when the game's over. And then listing out the tools, including the agents, the remote agents that have been wrapped as tools. Instruct the planner a little bit about how to plan. Don't ask the user for moves. It's just a lot of basic prompt engineering, just to keep it on track. Start game, get game status, wipe player, apply move, repeat until. And this is again the built-in planner. I've given it a bit more of a thinking budget because it has to do a few more things. Again, it doesn't actually use that up. So I've basically got a chess manager class that provides a bunch of functions. And I'm just pulling those functions in and wrapping them as a function tool, and then bringing in those two remote agents that I've wrapped as tools and giving them to this agent as tools, giving it 15 calls, some safety settings, and that's it. Now this time I'm not wrapping it as an A to A agent because it's just in the same file, so it doesn't need to talk remotely. Right. So what I'm going to do is just start this game. So what that's going to do is just send begin game off to the orchestrator agent. Okay, so okay, it's white's turn according to the game status. It's talked to the white. Oh, it's just checking if the white and black agent is still there. Okay, it's got a move for white. Is it applied the move? Yeah, it applied the move. Okay, white just made their move, and now it's planning what happens next. Actually, it might already be in the black player agent. Yep. It's not super fast because there's a lot of calls to LLMs going on, and this is one of the things that struck me is when you think about use cases for this, you want to think about use cases where you do a lot of reasoning but not much interaction, rather than lots of interaction with not much reasoning.
Can we see the UA?
Yes. Sorry, I'll bring that back up. So there we go. White's made its first move, E2 to E4, and it's now thinking about black's move. While it's doing that, I'm going to hop into the tracing tool.
So, an actual use for this sort of technology, the only one that springs to mind is CICD. Could be useful for applying this sort of thing to
Checking the code.
yeah, that's right.
Yep.
That's the only one I can think of. Though.
There's a lot of cool uses for this kind of stuff, and this is a really slow example just so that you can see what's going on. Basically, if you've got different services in different places, and you want to get information from them to use as context to reason about how to do something. So a travel planning agent that might look at what the tourist season is and what the weather's like, and then might look at the activities that are available using some other resource and decide what would be a good travel itinerary based on that. Yeah, well, you could use it for military planning, for sure. Just going to head back in. Oh, what have we got there? we had a little bit of a problem with this at the beginning of the night, and I'm not sure if it's completely ironed out. It might be. I might have pushed.
It's still happening.
Yep, let's see if it's made another move. No. I'm just going to restart it.
So what's going wrong?
Honestly, I don't know. We had a container that had a Python file in it that was basically running the chessboard. And as soon as that Python started, it threw a segmentation fault. And it hadn't done anything like that all week. And so I don't know what's going wrong is the answer.
Demo gone, frowned on you.
Yeah, absolutely. So I've just started this up again, and it's just slowly starting things up. So it started up the MCP server. It's starting up the chess user interface. And let's refresh that. Start the game again. Okay, so it started a new game. You can see it's gone and looked at the agent card for the white player agent. It's calling tools on the MCP server. It's got a move, so that's the move we saw before. Yep, it's a good move. Now it's black's turn. And this is where it hung before. Okay, so it got a move from black, so E7 to E5, and it's just applied it. So, not lightning fast. So, I mean, the goal here is not to play chess fast, it's to give you an idea about how all these pieces fit together in a real scenario, and maybe some ideas so that you can think about when this might be useful and when it might not be. Oh.
I mean, this may be the wave of the future, really, because you're probably going to have several AI agents talking to each other about all kinds of things.
Yep.
All the time.
So they effectively become microservices. So all the ideas that we had for microservices and all the security issues we had with them, we're going to re-encounter them with agents interacting with each other. What was your question?
Can they just change their tools on the fly?
You can certainly code them to change the tools on the fly. You can chuck tools into the mix that weren't there before.
So the agent card seems to get pulled quite often.
Yes. I don't know if it rechecks the tools. I think you'd have to actually code it up to make it recheck the tooling.
You mentioned the tools are stateless.
Oh, yes. So the player agents were stateless because they don't need to know anything. They just get the state of the board and make a move. But the orchestrator agent's not stateless because it has to manage the state of the board.
It's a new white player agent instance.
No, it's the same stateless instance. So it just makes another call which is completely stateless and unaffected by the previous call to that agent. Yep. So it seems to be going. So I'm just going to hop into
Looks like it's cost a third of a cent.
yeah. Let's look. Chess orchestrator agent.
I don't think anything's changed there.
No. So maybe the instrumentation stuff got mucked up when everything, because it's having to actually go out to the internet and send this, and there were some issues with the TradeMe network. But that one, oh, maybe that was one that I ran this afternoon. When was that? I don't know, 7:05. No, that's tonight. So, yeah, not sure what's going on there. So let's
Go back to the games.
let's see what's happening in the game.
Oh, looks like something's happening.
Almost over.
Yeah. It's actually a bit faster than a human game, though, I think.
Yeah, I think so. Possibly at this level, you wouldn't be making these moves this quickly, unless you had a move clock.
I mean, this is the sort of thing I see with AI. There's no point in this except as a teaching tool. Yeah, and I see the same thing with art. Art generated by AI is pointless. I don't see any
Yep.
art as a form of communication between humans.
Yep.
Getting AI to do it, stupid idea.
Yeah.
But yeah, they'll probably
Have,
come in.
have you seen that
Yeah.
quote that was doing the rounds? That I want AI agents that can do my washing and mow the lawns so that I can write poetry and paint.
Yeah.
One thing we talked about at my work is giving AI more access to production systems to do troubleshooting when things go. So often when things break, there's a whole bunch of different places you end up having to look, and you can kind of automate some of the drudge work of that away.
Some of the read access perhaps.
Yes, read.
Yeah. I'm just going to show you the MCP server because we didn't look at that before. It basically just sets up a chessboard. It sets up the Stockfish engine. That's what it does to start with. And then it sets up an MCP server. And Fast MCP is built on top of, I can't remember if it's Starlet or Fast API. I think it's probably Starlet underneath, which is what Fast API uses underneath as well. And then basically these are wrappers for some logic. So I've got a function that has the make move logic in it, and I've wrapped it with a make move function and told it it's a tool. The only reason I do that is because if I want to test this logic separately, I don't want the wrapper because the wrapper will cause PyTest to not play well. So I basically separate out the logic from the tool so I can test the logic separately and then put it into the tool. If I put the logic straight into the tool, I can't actually test the tool without doing some really clever stuff. So yeah, basically a bunch of tools that wrap just standard Python functions. And that's it. mcp.run transport streamable HTTP server import. That is the whole MCP server, which I think is pretty nice and clean.
Stockfish is the master chess master.
Yeah, so up here at the beginning, it just basically uses Python chess to create a board, and then it basically uses the Stockfish Python library to access the Stockfish engine, which is basically an executable that's sitting on the system. And then it asks it for, it basically gives it the UCI and asks it for a move. Let's have a look. Yeah, and that's it. So, but basically it sets up a chessboard, it gets a move from the engine, and I think it possibly, does it actually check? It's got some tools to check if it's valid. I'm not showing those here, but if you have a look at the GitHub repository, you can see those. And how are we doing? Who plays chess here?
I know the rules.
I don't need to know the rules because the chess engine knows
Yeah.
whether they're valid moves or not.
Looks like a good game.
White's list of pawn.
Did you manage to identify any one thing that's bottlenecking the game into running so slowly?
Basically, every tool use is a large language model call. And if we're using a thinking model, which we are in this case, then that takes time because thinking models generally tend to be slower. And this generation of models are often a lot slower in terms of returning results. So a lot of the latency is just in the call to the LLM and waiting for the result to be returned. And when you're making lots of those, like to each tool and then to plan and then to replan and to validate a move and check a move, you've got to think about all of those, and all of those are adding seconds to the process. So you want to think about those LLM calls and think, are they actually doing something quite useful? Like these are really simple calls and they're taking quite a long time. Whereas I could actually give it quite a complex job and it would take about the same amount of time as well. Yeah. Does that help?
Yeah.
How do we think about it? Well, I've never really understood what a thinking model is, like
Okay.
compared to a static
Yep.
model. What have
So-
we done?
Yep. So when you make large language models, there's two parts. Well, there's more parts these days, but there's two basic parts. One is the pre-training. So you take a really large set of data and you basically tune the model to produce completions. So completion is to make an accurate prediction of what would come next given what's already there. Okay. And that's why large language models hallucinate, because given insufficient context, they will just predict what would come next. And that's believable statistically, but in practice, it's not factually accurate. So that's the first part of the training. The second part of the training is reinforcement learning. So it's given a whole lot of examples of interactions and expected outcomes, and it tunes the model to basically produce those outcomes from those types of interactions. So it makes the model more human-friendly. The recent set of models like DeepSeek, what they did was they created a window in the output of the model. And it's basically like a bunch of HTML tags. It just basically says thinking tag beginning, thinking tag end. And then it has to put its thinking between those two tags. And when they trained the model, they asked it to try and lengthen the amount of time it spends thinking, literally. And if you look at the training graph of the model, the amount of time basically extends inside that thinking window as the model is trained. So they're forcing the model to learn to think longer. It's called test time, I can't remember what the name is, test time inference or something. And that's what these new thinking models do. They basically have a window inside the output tokens that contains thinking, and they're forced to, the model's forced to think longer. It's been trained to basically think about what it's doing. And if you look at the paper for DeepSeek R1, there's things like actually the model having aha moments. It's sort of like does something and then it goes, oh, so that's how that works. And then it goes, aha. And it literally says aha. And then it goes and reasons about what happens next. So yes, that's a long answer to a short question. Thinking models have a thinking window that's been forced to be extended so that the models don't just give you a quick completion, but actually cogitate before they give you an answer.
They go, I've read a few things where they simulate cogitation.
Well, we do too. So don't think that we're too much different. We confabulate stories to describe the actions that we take. And we can actually measure it psychologically. You know, we do something and then we create a story for why that happened that way. And it might be true, or it might not be. And that's quite often what you see with these models is their reasoning might not actually reflect what they do when you instrument the model and see how it reasoned. But forcing it to reason longer makes a better model.
So is this thinking, the thinking AI, same as maybe Google's deep research option versus, Gemini's deep research versus their normal Gemini?
So deep research is basically an agentic system like this, with a bunch of tools that allow it to go out and find information, to think about the information, to generate ideas from that information and look at new research sources. So it basically creates a growing tree of information and then it narrows it down to come up. So it's basically using agentic systems like this to force thinking models to actually think longer by doing lots of thinking and interacting with lots of context to come back with a really rich result. So I don't know if we'll get to see the game end. I will show you Gradio just quickly and we'll finish there. So this interface is built using Gradio. Where is it? Here we go. So it's really nice if you want to build something like that. Gradio. You literally just have to describe it. Import Gradio blocks as a demo, which is a context manager. Then inside that, I want some markdown. I want a row, a text box, a button. I want an image. When I click the button, I want it to basically call the function, which is generate image and display it. And then when you do demo.launch, it basically builds the whole web interface. It takes a moment and sets it up. And one of the really cool things with Gradio is that it will provide you a public IP address and tunnel the results of your Python function that's running in the background into that so that you can share it with someone else. So you can have something Python running on your own computer and share the interface with someone else on the internet. Yeah. So there it is down there. So it's a really nice tool if you want to just build up something quickly to interact with some Python code and just have a nice UI that you can play with. And that's all I've used to build the chess interface.
How much work was it to, because it seems like Gradio is really good at kind of simple UIs.
Yep.
This is quite different to that.
Yeah.
Quite a lot of
So this is actually really simple because all of this is rendered using the chess engine. So I basically just...
Oh, right, so it's an image you're getting from the
Yeah,
chess.
literally,
Right.
I'm just rendering an image here. And I just basically say, what's the current image for the state of the board?
Right.
And
You're actually rendering the board.
no. So I'm just rendering that on a 1 second timer. So it's actually not rocket science. There's a bit of cleverness in here. There's things like, this actually took a lot more code than the actual chess engine setting that up. Honestly. And it's also, I set up sessions in here so that more than one person could interact with it and so that it could pass the sessions onto the chess engine. And the chess engine's running singletons per session of the chess manager and then passing those sessions on to the agents. So you can get into some pretty complex plumbing if you want to go for it. And you can chuck in JavaScript and styles as well if you really want to make it beautiful. But just out of the box, it's actually pretty powerful. Yeah.
What are you doing for agent ops to be able to pull back your...
All right, yeah, let me show you that. So let me go over here. Ooh, it's a fast web connection, isn't it, Simon?
Sorry, it might be
No,
offended.
that's okay. It'll get there. So, where's the import? Oh, it's in there.
It's at the top. Yeah, that's it. Asian ops.
Yeah, so I literally just import agent ops, and then I've got it keyed on an environment variable so I can turn it on and off. And then agent ops init API key tags, which is going to send to the agent ops web interface, and that's it. It instruments the agent.
So is it all running on your machine and then making calls to do the AI stuff? It's not running on their server and then making calls to your machine?
No. So ADK is making all the calls to the Google large language models. This is just instrumenting the agent so it can track those calls and track the costs and all the interactions so that you can see, where things are costing you a lot of money and where they're not and where you could get efficiencies.
And it knows how to tie in with the agent framework
Yes.
you're using, but
Well,
know lots of them? Or
yeah, Agent Ops knows Llama, LangGraph, small agents. I think it knows Pedantic.
so it will dynamically look at what's sort of
Yep.
in use in the program.
Yeah, it wraps it in. Yep. So it does some clever reflection in the background and works out what it needs to do and wires it all up, and you don't have to think about it. So I actually think that's quite a cool feature for a production system. Yeah. And I think it also has open telemetry compatibility, so you don't have to use a proprietary tool like this. Cool.
Who's winning?
Where are we up to? Would we say we're in game yet, or still?
I think it's stuck, 'cause I think it was on this move for a while.
Oh, okay. Maybe it has got jammed up. Let's have a look. No.
Just echo.
Pretty close.
Apply
Maybe-
move.
Maybe it's actually moved ahead a little bit further. The board looked kind of similar to action. If you consider it.
Sometimes you get in-game loops where things just move around in a cycle, and I think there's an in-game rule, like something like the 50 move rule. If you've just been walking around the loop, it's called. Yeah. So I don't know. It was a fun exercise, and mainly for me, it was trying to understand these technologies and how they interact with each other and how you wire them up. It's come a long way. Like what I showed you today is actually a very small amount of code compared to what I would have shown you 3 months ago when I did the original talk. A lot of it's just wired up in the background for you now.
So has anybody found a killer app for it yet? It looks like it still has that feeling of a solution looking for a problem.
There are lots of really cool apps that are using this technology already. Yeah. You're probably already using some of them and you don't even realize.
What are a few big ones?
I'm neurodiverse. I have ADHD. There's a thing called goblin.tools, which basically uses just some basic agents to do tasks like I give it a job and it'll give me a task breakdown, and I can tell it how much detail I want it to go into. And there's other tools like that that will go out and look at your schedule and work out where it can schedule those tasks in and fit them into your day and keep track of things. So it's a lot of sort of cognitive offloading, things that you would have had to do and try and keep track of that you can actually hand off to a tool that becomes a second brain for you. Yep.
It's a lot of tokens. What kind of caching do you have with
Um, yeah, I'm doing no caching here, but yes, that's probably why it's like racking up 4 million tokens. But yeah, I mean, some of these calls will be identical, and if they're cached, then there's no reason why they need to run again. So a quick look. Cache credentials. Oh. Generate a cache key based on requests and arguments. So that's caching context. I imagine there's some plumbing in here for that kind of thing. Yeah. I mean, there's a ton of tooling in here. I mean, you've got all these function tools, third-party tools. You can run your tools on Google Cloud. You can interact with other tools that are run by other systems. Different types of agent runners, stuff for running sessions and memory and session scopes and callbacks and artifacts and events and context and observability and evaluating your prompts. And yeah, I mean, there's a full toolkit here, and I think Google's actually done a pretty good job at fleshing out all the bits that you'd want. There are other players that are starting to catch up in that space, or doing their own, roll your own version. Yeah, I chose ADK because all of the plumbing for A2A's been done, and there's not too many other systems that are doing that at the moment, and it was easier to show you guys what's going on. Yeah.
This is more of a meta question. That
yep.
The prompt you wrote for one of the agents was, for the main
yep.
agent, you had to. It was almost you were almost writing a program.
Yes.
Just at a much higher level.
Yes.
Than you would normally do.
Yeah.
You had to be quite specific. Do you think that one day we're going to end up with this new programming language, which is how we talk to agents?
Yes. Well, I think we're already there. There's already a move away from English prompts to JSON-based prompts because these models understand JSON much better. I don't know how long that will take, but these models are actually trained on JSON for tool calling. So JSON-based prompts are much more structured, and they can understand the structure better.
So you have to write JSON to create a prompt for?
No, you write your prompt, a structured prompt, in the form of JSON. I mean, you can write a prompt as a piece of Python code if you want to. I mean, that's the thing with these models. If they understand Python code, then if you describe it as a piece of Python code, that's a valid prompt. So prompting is code. But JSON's just another structured way that it has been trained really specifically on. Microsoft's just brought out something recently called Pommel, which is basically a way of describing prompts. But there's also tools for tuning prompts now. There's a package called dSpy, and it has a tuner. Can't remember what it's called, grepper or something. And it basically breeds prompts. So you give it your prompt, and you give it a couple examples of inputs and outputs that you want, maybe 10 examples. And it will actually tune the prompt by taking bits of the prompt and treating them as like genetic chunks and breeding them. And it sounds ridiculous, but it's incredibly successful. It's actually much better than anything we've had before. And if you change your language model out and your prompt stops working, you can just drop it straight into this as part of your prompt ops and have it retune it for that new language model. And it will literally take your prompt, take what you want, and work out what the most optimal prompt for that language model is. And it also tends, grepper, I think it's grepper, tends to crunch down the prompt. So you get really compact prompts that have very few tokens as well.
Give the same kind of results.
Give the same kind, or even better results, because it's tuning the prompt against the results. It's not reinforcement learning, but it's kind of a adjacent idea. Yeah.
certain prompts to change the
Yep. Well, your prompt engineering then becomes part of your software development process. You start with initial prompt and a set of inputs and outputs that you'd like, and then get it to design a prompt for that.
tagline just is quite staunch. It's programming rather than prompting LLMs.
Yes.
That's a great.
I heard a new word, vibe coding.
Yeah.
It's the new and it's basically writing software by.
Well, vibe coding was Andre Karpathy's brainchild, which is basically you just describe what you want to build, and then let the tool build it, and then if it fails, you feed the errors straight back into the model and let it rebuild.
If you're fully vibe coding, you don't even look at the code. You don't even.
You just let it loop.
Look, this describes me because I don't know any program at all. And
Yeah.
I'm building a pipeline.
Oh, we're getting there.
Yeah.
Yeah.
You're vibe coding.
Yeah. So that's vibe coding. I don't think it's tons of use commercially unless you want to like knock up a quick prototype that you don't really care about maintainability putting in production.
These models aren't good enough for that.
But AI augmented software engineering, which is where we're heading, where you work alongside coding agents or alongside a team of coding agents to generate your code and wrap processes. Ooh! That's the way we're heading, putting structure around it to make sure that we get consistent results.
I don't think it's almost a stalemate.
But there's some semantic diffusion there where vibe coding is increasingly being used to describe basically any kind of AI assisted coding, right?
I don't think Andre Karpathy really did us a great service with coming up with vibe coding.
Vibe is a verb. It's useful as saying literally now.
Yeah.
This is a vibe meetup because it's really chill.
Yeah. I got a good vibe about this. Does vibe have a place in commercial software processes? Yes, for quick prototypes to put an idea in front of a customer and say, is this of value? Absolutely. But it's throwaway code. You probably... What? Yes, absolutely. Digital wireframing. And even just like product engineering, moving away from just writing code towards becoming a product engineer, saying, actually, what do you want? Okay, I've just built this. Is this it? Or do we get the model to tune it? And so, yeah. So I think it's good for those customer interactions, but a lot more process needs to be wrapped around it for real products. How we going?
Seems to be getting.
I guess what vibe coding also does is allows people who previously couldn't write software to write software.
Absolutely.
So you could, in a commercial setting, you could have someone in sales who's been talking to some customers, has got some ideas, and has kind of put something together to show people and sell the idea internally. Let's build this thing. You know,
Yep.
And a bunch of people creating unique things. Like I think GitHub's going to explode pretty quick with guys like me.
Yep.
We're starting to put things up, and I have no idea how to code, but I can create fairly useful, complex tools to do things that probably not many people would want, but some people do.
Yep. Yeah, I think it is democratizing software development.
That's it.
I still think there's a lot that you need a developer for that's going to get you in trouble if you vibe code. When you get into maintainability and scalability and reliability, you're not going to get those from a piece of vibe code. And the coders that are really having success with vibe coding are the senior engineers, because they know when the model is producing crap, and they can basically make it do what they need it to do. But for a novice, you don't know if it's good code or bad code. Your only assessment is it worked, and it produced.
Writing code is only a small part of the skill set required to be a professional software engineer.
Possibly.
Who would have thought?
Yeah, it's all the knowledge that goes with it.
Yeah.
Yeah, that's what's valuable.
battle scars.
experience,
Yeah.
knowing what's going to work, what's not going to work down the road.
That game's going down to the wire, by golly.
Yeah, I think it's going to be stalemate.
Have you done any benchmarking how these chess players perform strategically against like other chess robots or real players?
Well, he's made it so that it's the same player is controlling both black and white, so that this would tend to go to a stalemate anyway, wouldn't it?
Yeah, so I mean, Stockfish is playing Stockfish.
Yeah.
So it will often end up in in-game loops.
But the strategy isn't coming from Stockfish, right? That's coming from the agent.
Yeah. Sorry?
The strategy isn't coming from Stockfish, right? That's coming from...
No, the strategy is coming from Stockfish.
Oh, okay.
Because Stockfish is just going, what's the next best move given this board position? And Stockfish can, Stockfish has an in-game book that can see the end, I think 8 moves out. So the in-game box basically tell it what is the moves from here to the end of the game from 8 moves out. But you do get into insufficient material and in-game loops and other things. Oh.
Pretty close.
Anyway, it was a fun project and I thought I'd share it with you.
Thank you very much.
And you get to learn a few things along the way.
Thank you very much.